The purpose of this hands-on activity is to measure the density of a piece of stone or metal using a rubber band scale which you calibrate yourself. You will need some rubber bands of the same type, 2 water bottles, one full and one empty, some string, a ruler, and a stone or piece of metal which weighs less than the full bottle of water, and a bowl of water. To make the scale, link the rubber bands 4 at a time until you have 10 links in your chain, and attach a piece of string at each end. Once you've finished the chain of rubber bands, hang the full bottle of water on it and measure the length of the rubber bands from the knot at one end of the rubber bands to the knot at the other end. The weight of the bottle is the volume of water in the bottle multiplied by the density of water multiplied by the gravity constant g. Pour half of the water out of the full bottle until the levels in the 2 bottles are the same. Measure the length of the rubber bands and repeat until there is only 1/16 of the original water left in the bottle. Plot a graph between the length of the rubber bands and the weight of water in the bottle. You can now measure the weight of something using the length of the rubber bands. Now we will measure the density of the stone. First, we measure the mass of the stone by measuring the length of the rubber band and converting to the stone's weight using the graph. Next, we measure the weight of the stone by suspending the stone in water and measuring the new length of the rubber band, which we convert to the stone's weight when in water. From Archimedes' principle, the difference between the weight in air and the weight underwater is equal to the weight of water displaced by the stone. We can find this volume using the equation on the screen. From this, we can calculate the density of the stone. If we measure the weight in air to be 230 grams and the weight in water to be 170 grams, we can calculate that the density of the stone is 3,833 kilograms per meter cubed. Since this activity is a complete process with making apparatus, calibrating it, and then using it to measure a physical quantity, your students will better understand what they are doing when they use commercial apparatus.